Hi everyone, welcome to this video on angle pairs. So as we've seen already in geometry, we have several different things that we work with as our basic building blocks. Points, lines, planes to be exact, and then we create other objects out of those. So lines, segments, rays, and so on. And as we said, one of the things that we can create using two segments, lines, or rays is an angle. And then as we add more complex shapes, we will find several specific types of angle pairs. Just to review, we have several different types of angles. So we know that if we have an angle that measures 90 degrees, we call it a right angle. And that's the symbol and what it looks like. So we have our angle that's kind of that perfect L shape, and a little box inside of it says that's a right angle. We have obtuse angles, which is any angle that is greater than 90 degrees but less than 180 degrees. We also have, if we have a picture, we can look based on the shape. Well, this, if you look at this, a right angle would look something like that. So we say this is an acute angle, as is this one. And we say that acute angles are any angle that is greater than 0 but is less than 90. And then the other type that's not stated here is the straight angle, which is equal to 180 degrees. Now, as you may know, yes, we can talk about angles that are greater than 180 because we say that all circles have 360 degrees, for example, so we know they exist. However, we don't talk about those unless we are specifically inside of a circle. So now that we've looked at that, we can talk about different angle pairs, okay? So between the two angles A and B. Now, they've given us 4 choices. Alternate exterior, I will tell you right now, can go away. That is only applied when we have 2 parallel lines cut by a transversal. That's not what we have here. These are what is known as adjacent. A pair of adjacent angles, they share a vertex and a common side. So in what we're looking at here, angle A is here and angle B is here. We see that they share the same vertex, right, where the two sides come together, and they share that side that now has turned green. They are adjacent. Both of those things have to be true. They have to share both a vertex and a common side to be considered adjacent. The next one is what is known as a linear pair. Okay. We have a straight line here. Linear, right? Linear means line. And what this is, what these angles do, what I want you to notice here, is a linear pair is a pair, obviously, of angles, I'll use the symbol, that split a straight angle into pieces. It does not have to be 2 congruent pieces. They don't have to bisect it. They don't have to divide it in half. It just has to divide them into 2 pieces. So that's what we have here. That straight line that I've highlighted in blue has been split into 2 smaller angles, A and B. Okay. This one is a little bit different. This one is vertical. Vertical angles, there's not exactly a good way to describe them other than to say they share a vertex but no common side. Now, if you have that, and I'm just drawing a random angle here, I don't have vertical angles in that case, this that I've drawn here. So it's not any angles that share a vertex and a common side, but that is the basic definition. The other way that I tend to think about this, if you look at the highlighting, I call them the bow tie angles or the X angles, meaning they're angles formed by two whole lines, okay? And then you have one on one side of the X, one on the other, where A and B are. And the angles, if I call them C and D here, are also considered vertical. So that's the second part. So they have to have a common vertex but no common side, but also have to be made by two lines or rays crossing in the middle, not just four random segments that meet at a point. Okay. The last one here that we have for multiple choice is complementary. Complementary, remember, those are angles that sum to 90 degrees. And we know that these will sum to 90 degrees because we have a 90 here. That's that right angle symbol. And if I have one right angle, I have another one right next to it. And because these two, A and B, they split that right angle. Remember, A is right there. They together make a right angle, right? Because angle A plus angle B will be that 90 degrees, and that's exactly the definition of complementary angles. All right, so just some quick practice with values. Find the measure of the unknown angle B. Okay, now this one is just like the one we looked at in the last slide. We see here that we have one right angle given. We know that the angle on the other side must be right as well. And then from there, so B, remembers right there, we know that 27 degrees plus the measure of angle B, so lowercase b, should equal 90. And remember that this notation means measure of angle. Okay, so then we would just do algebra with that, subtract 27 on each side. So I would get the measure of angle B is equal to 63 degrees. Right? Slide 8, same thing, but I have a variable now, but that doesn't matter. I would say 39 degrees plus 2x plus 1 equals 90. And then the only difference here is you have some like terms to combine as well as the variable. So I would add 39 and 1, subtract 40 on each side. I'm going to get 2x equals 50, divide by 2, and x is 25. Remember, they said that they wanted the measure of the angle. The measure of the angle is actually 2x plus 1. So I need to plug that 25 back in. So I would get 50 plus 1 equals 51 degrees for my final answer. Always pay attention in geometry to what you're being asked. Sometimes you will just be asked to find the variable, but in a number of cases they will ask you to plug it back in and find the measure of an angle or the length of a segment. This is a linear pair. And we said that a linear pair splits a straight angle into two pieces. This means they are, remember, supplementary. And supplementary means they sum to 180. And that is a fact. Linear pairs are always supplementary. So we're going to say that B plus 128 degrees equals 180. Subtract 128 on each side. And I'm going to get B equals 52 degrees. Okay. One more. I have another linear pair here, so it's supplementary. I'm going to take those two pieces, 3x plus 2 equals 18 plus, whoops, I did the one thing that I always tell my students not to do. We know it's a linear pair, so we know that it is supplementary. We don't know that they are equal, so I shouldn't have put that equal there. I have to add them together, and they should be 180. Add them together like terms, so I would get 3x plus x is 4x. 2 plus 18 is 20 equals 180. Subtract 20 from each side, so I get 4x equals 160. Divide both sides by 4, and x equals 40. I want the measure of the unknown, and we'll say angles because there's two of them. So I would say 3 times 40 plus 2, that's 120 plus 2, or 122 degrees. And I would say 18 plus 40 is 58 degrees. Those are my two angles, and I can check that and see that they do add to 180, so I do have the correct pair of angles. All right, so those are our angle pairs. So in terms of their arrangement with each other, we have adjacent, share a vertex and a common side. Linear pair, two angles, two adjacent angles that split a straight angle into two pieces. Vertical angles, the bow ties. And complementary angles, which divide up a right angle into two pieces that sum to 90. And from there, we also saw that if we have a linear pair, it is automatically supplementary, meaning the two angles sum to 180. Thanks for watching this video on angle pairs.